Hi, thank you guys for joining us today. I got a very special guest here, Remoun Metyas. Thank you for joining me. He is a senior software engineer on our blockchain platform team. And I invited him on to the show to talk about the block metadata proposal. And Remoun, tell me, how did you end up working at MobileCoin?
Yeah, so I joined MobileCoin in January. Before that, I was working on Kiva.org, helping them scale up their serving lending platform that has served them for 15 years. And before that, I worked at Waymo, helping make self-driving cars happen. And before that, I worked on various parts of Google search.
Wow, that's pretty cool. I've been always impressed with what Kiva.org has done. And I see the Waymo cars driving around my neighborhood all the time. So pretty impactful products. Maybe we can talk a little bit about the impact of MobileCoin, but also the impact of your proposal on the MobileCoin blockchain. I'm going to share my screen throughout this call and kind of like walk people through how to like find your proposal. But is GitHub sort of the best place to dive into this?
Yeah, that is our source of truth. And I see you started on the MobileCoin website, so we can go to the developer portal, which is expertly maintained.
Thank you. On the developer homepage, you can see all of our documentation. And if you scroll down, you also see all the research and development work that we're doing, proposals, grants, bug bounties, Gitcoin bounties, security audits. If you go to the proposal section, we actually have a link right to the GitHub repository. And that takes you to this page, which has a description of how the process works. But if you want to see the actual proposals, they're in the text folder. But the proposals, before they actually are accepted, are actually as pull requests. Is that right?
Yes, and that is the status of the block metadata request that we'll start discussing.
So if you go to the pull request section of MobileCoin Foundation MCIPs, or is it MCIP or MCIP, MCIP?
There's no standardized pronunciation. It's an acronym. We typically pronounce it MCIPs, but since it's a CI, MCIP, I don't think anybody will, people will figure out what you say. But yes, typically, from what I've heard thus far, they're often pronounced MCIPs.
Okay, I'll start calling them MCIPs.
Cool.
But if anybody calls them MCIPs, we can have one of those GIF and JPEG wars.
Yes.
Yeah. So this proposal at the top of it, like block metadata. I love the words that are in there. Like, I know what metadata is because, you know, we've all had the scare of like people accessing all your metadata, and you know that like this data is attached to everything you do, and you know there's always timestamps and senders and receivers. So what is the metadata that we're talking about today?
So it is a little bit analogous to for the sender and receiver bit. This, as the description says, it contains the quorum set and a tested verification report of the consensus node that externalized that block. What that means is we are basically adding a little bit more signal when a consensus node externalizes a block. That means the consensus protocol agrees consensus upon those blocks, upon one block at a time containing the various transactions. We include two things. One is, as viewers of this video may know, and I'm sure you do, MobileCoin relies on SGX, Intel SGX, secure, I think, software guard extensions. They basically provide us a private, secure enclave. One of the things we get out of those is an attested verification report that lets you verify that your code is running in a secure enclave unmodified. So this is an addition to each block to include information about the network configuration at the time the block was externalized. One of the key things is, the enclave that is actually externalizing this block. This lets us verify that the block was produced by a MobileCoin enclave, secure enclave, and also gives us additional properties that I can talk about in a moment. But yeah, so this gives us additional signal. It kind of tells us about the consensus node that sent the block, so to speak. Okay. One thing to note, and this is mentioned in the text, this doesn't let us fabricate blocks. It just gives us a little bit more signal to authenticate the blocks.
So let's, I see there's a lot of comments
A bit of activity. Yep.
in here, a lot of really good discussion from others in here. So if you want to see sort of like the community and other developers diving in, it's kind of fun to read. And this is actually why I asked you to speak, was because I saw all the discussion going on from here, and you've already got some approvals. So it looks like this proposal, you put this pull request in, like what's the time frame that you feel like this is gonna happen?
I was actually mentioning in our stand-up this morning that I'd like to move this particular one to the final comments phase, which is another a final date for comments, and then we merge it and proceed. But yeah, let's click through to the rendered proposal and talk about it a little.
So the rendered proposals are just much like a nice long form view of the documentation for that pull request. So it's kind of like the human readable version. And we're gonna actually, I want to bring this and bubble it up to our website so people can read the rendered versions rendered on the website. But it looks like there's a nice little contents summary motivation, and so maybe we should dive in.
Yeah, let's start with the
kind of gave us a summary, but yeah,
exactly. Yeah, so the attested verification report is encrypted data signed by Intel's attestation service, I believe it's called IAS, that gives us verification that the enclave is what we want it to be. And the quorum set is the network of nodes that is a key part of our consensus protocol, where there are a number of machines. Some of the nodes are operated by the MobileCoin Foundation. We have various nodes operated by a few other partners. And yeah, so the quorum set is for each node, the configuration of which nodes, like when they reach they reach an agreement, say 8 out of the 10 nodes that are in the network must agree on a block before it's externalized. So this includes the quorum set to in the block, a mention of, or next to the block technically, a mention of a record of which that quorum set configuration of the machine. And the attested verification report includes another key piece of data that is useful, which is the public key of the enclave, which is used to generate the block signatures, which is a key part of authenticating the authenticity of the blockchain, because that block signature is a hash that includes the block ID, which itself includes a hash of the contents, so that it's basically a bunch of checksums that lets us trust the integrity of the block. And this gives us an additional layer for the secure enclave part of this process. Okay,
so if I'm following correctly, this block data metadata already kind of exists.
We're adding, it's not on the blockchain, but yes, and this is data that exists that we're capturing, and arguably, ideally, this is something that we would have had from day one, but we are adding it now, and including this, as this proposal describes, sort of a mechanism for kind of capturing the history of the blockchain that is not in the official data. And going forward, once this is implemented, any blocks that are uploaded to the blockchain in S3, they will include this metadata, as well as, actually, if you scroll down a bit, it shows the, so archive block is the format of the protocol buffer that describes the data on the S3 buckets. They include the actual block header, the block contents, and a signature. And what we're adding is a fourth field with block metadata, which itself contains a signature, includes contents and a signature over that to give us that cryptographic guarantee. So if you scroll back up, so block metadata includes the contents and a key and a signature, and the actual contents includes the block ID for making sure we're talking about the same block, the quorum set, and the verification report, which each have their own structures to represent them. Okay.
Yeah. And it notes in here that the ledger database and the watcher database also store this information. So is this also going to change the code for watcher and ledger? Yes.
And in fact, this is one of the proposals where we are actually working. We have the proposal out in parallel with implementation. So I have a pull request to the official MobileCoin repository, which includes the foundations that starts wiring up the ledger and consensus nodes. I believe it is pull request. There was a series 2058, 2052. I believe is the one that actually wires up consensus and watcher.
Is it on the MobileCoin official?
Yeah, if you type MobileCoin in that search box, you'll get the official repo.
Oh, on the foundation or the?
Yeah, it is under the foundation, and I will
Okay,
send you a link for convenience.
Oh, great. Thank you. Oops. A little shortcut. Thank you.
Yeah.
Okay, so okay, great. Thank you. So
Yeah.
this is the
So this is the actual
pull request
implementation.
on the MobileCoin repo on the foundation GitHub. Great.
Yes, this is part of a series of pull requests that are implementing this proposal, and there are still parts that are actively in process, and some more work that we are aiming to complete this in the next few weeks, in fact.
Great. I like how we've got links to the block metadata
The actual MCIP that we're just discussing,
right
because
here.
that is the motivation and context,
Great.
as well as some of the specific technical details, and then this is the encoding of that, well, partial encoding of that logic into the repository.
And looks like we've got a looks good to me from one of our blockchain leads, Aran, and yeah, I see we've got some unresolved conversations to go through. So
yep, in progress.
So we're getting there, and this updates the consensus, ledger, and watcher. So it's nice to like add this data. Anytime we're adding data and we're like adding metadata specifically, privacy pings in my head. So how are we protecting privacy in relation to this commit, or is this sort of like necessary?
Yeah, it doesn't include any of the data of the actual transactions. It basically, so it includes data about the machine that generated the block, and the contents are signatures and hashes of the data. So a fingerprint of sorts of the transactions ultimately ends up in the block ID, which is then ends up as part of the block metadata. But these are a series of strong, many of them thoroughly proven, and the ones that are unproven just means that nobody's found an attack, but we don't have a formal proof, but we do have confidence in it. These are all encrypted and cross-referenced in a way that gives us these additional guarantees, but they don't include any information about the transactions within it. It is more about the network topology and the process of adding that block to the blockchain. We record some additional signal that is part of that process. And here you see in the proposal, so for these AVRs, the attested verification reports, we don't have that data for the nodes up to and including the ones that are being published right now. So we're defining and are currently in the process of implementing mechanisms to provide historical context for blocks that don't have the metadata, and then going forward, you can just pull the metadata from the downloaded archive block.
That's a pretty important little step, just to make sure it's all backwards compatible throughout the history of blockchain, right?
Yes.
Okay, great. The rationale, I think I understand. We're trying to make it easier to verify the blockchain with fewer data sources, but does that speed up? Does that have any performance improvement? Like what's sort of like the benefit to the end user?
But it is actually and part of the motivation for this, in addition to it just being a very useful feature for the blockchain, and additional consistency guarantees that we get with the blockchain. It is a building block for another proposal that actually merged earlier, but is actually scheduled for the following release, called block streaming, which continues to be the main thing I'm working on currently with MobileCoin. And I'm not the only one, by the way, working on any of these. I have a few teammates from the blockchain platform team. I just happen to be the one who published the MCIP.
Okay. Well, I mean, as the publisher of block streaming, so it sounds like this block metadata is really to implement like an overarching solution for block streaming. So what is block streaming?
Yes, block streaming is changing how the consensus node actually publishes and distributes, or how we distribute blocks generally after consensus has done its thing. Because we have the various consumers, including FOG, which is the entry point for the mobile SDKs, including Signal and the Mobi app. So currently the blocks, and the source of truth is there are canonical S3 locations, Amazon S3. So you can anybody can download the data of the blockchain and run the verification and verify the integrity of it, and with MobileCoin's guarantees, they can't actually see who sent what to whom, but
Yeah.
we can agree on the data that is there.
We're agreeing on all the digital strings of random encrypted data, all match the other digital strings of random
encrypted data that is by definition indecipherable from or indistinguishable from random data, but it's not all.
True. It's not random, it's oblivious.
Yeah.
Oblivious data.
But yeah, the way things are currently read, we actually upload the block to S3, and then the various consumers just pull S3 for that, which is inefficient and ends up accounting for about, we have like a second of uploading to S3 and then another second of downloading from S3 across the network. That is the end-to-end time for a transaction to go through. So that ends up being about 40% of the 5 to 6 seconds that it takes today. We won't be able to shave all of it away, but that is a potential 40% reduction in the end time for a transaction to clear and be an official part of the blockchain.
Wait, what? Are you saying you can reduce the time for a transaction by like 40%?
Up to 40% of what that is the time spent today.
Let's not guarantee.
Yeah, I won't promise 40%, but it's up to 40%.
That's the estimate. That's a pretty significant improvement in terms of speed and performance. So
right, because
and it also eliminates the
storage format. And so if we have a proper publish subscribe mechanism for the various consumers, including other consensus nodes, to observe what a consensus node emits, we're expecting to significantly reduce that 40%. But I wish I had firmer numbers to give you, but we don't have that.
Well, that's okay. Well, you know what? We'll know the numbers and what was your estimate, like a few weeks once we get
the block metadata and another couple of months for the finished block streaming.
Okay.
I'm guessing end users will see the benefits of all this hopefully by the end of the year. That's roughly, so Q4 is the current sort of estimate for.
Yeah, we won't give exact dates, as never tell anyone the date, because this is an open source project with decentralized governance and a technical committee that has to vote on everything. So everything depends on acceptance criteria that are managed by the open source community. So we can't guarantee any timeline, but really exciting to think that like we are going to be even faster than we are today. And I mean, I'm excited about that. That sounds cool. Also, I used to work for decentralized cloud, and I'm just a big fan of moving things that are less dependent on centralized entities. And S3 is a centralized company, is one of the most stable solutions used by a lot of people. A lot of corporations run everything on S3, and so this reduces our dependency to pull S3 as a solution, right? So,
and to an extent, where like S3, and there may very well be other places we publish, but that is one of the canonical publishings of the thing, and we're not removing that thing from S3. We're just removing it sort of from the critical path. Where everything has to talk to S3 to get the latest data. We're actually adding an additional mechanism. Now, for things that are, for nodes that are coming up online or catching up on the blockchain, they can still download the data from S3, and that's where the block metadata comes in to kind of help verify that the thing you downloaded, the blocks you download are the same, you gain cryptographic guarantees that they are in fact the same blocks that you can get by just observing the upcoming streaming APIs.
Yeah, S3 is great for as a bootstrap, but you don't necessarily like. I see this like in that very small window that you want that transaction to go. You don't necessarily want to be calling APIs to and from a different technology or a different database. Jumping down to like the rationale for block streaming, like it seems pretty obvious to me. Like I vote yes. If I had a vote on the technical committee, I would say, let's do anything that can increase our speed, right? But speed is not the only thing that we care about. Privacy, security. So are there any like drawbacks or things that have slowed this down, or like what are some of the things that we're thinking about before we deploy this?
Well, it works out that you have the rationale section on there, as like you just mentioned. One of the key things, I mean, this doesn't directly impact the privacy properties, so those remain. So the thing we maintain, actually, I mean, it is an ongoing concern, and this doesn't inherently affect that. But one of the main constraints that affects the design of this process is the maintaining decentralization. I think the third paragraph is one of the alternatives is to have the MobileCoin just run a pub sub service, but that becomes but that is a centralized service that we don't want to bring up to maintain that decentralization. So
I love that you have the alternative there as like, hey, we could use a centralized service, but we're not going to. So.
But that's and to,
I also appreciate that you've given credit to Streamer, Ethereum, and IPFS for their prior artwork, not artwork, but prior work.
I guess that is irrelevant for the space. Yes.
And so I think each time we do these calls, we should give credit to the former, ideas and white papers that we leverage. So I appreciate that you called those out. Is there anything that's missing from the prior art, or like you feel like was really useful in creating this?
Well, the fact that these sort of examples exist is encouraging. I am admittedly not yet familiar with those details, and that is part of, and hence you'll see that unresolved questions is the specifics of the pub sub implementation. So there's the core idea, which makes sense, and that's what's the discussion here. It is left as a sort of implementation detail that we will iterate on to find the right balance and mainly for performance tuning. But
Great.
yeah,
well. I'm gonna pause the sharing there, and cool. I think you did a wonderful job of explaining your proposal, and I hope that the technical committee all votes yes and accepts your proposal for block metadata. Is there anything else you'd like to add?
Nothing else comes to mind.
I think we covered it well. Well, have a good day, and thanks for talking to me. Bye, Remoun.
Yeah. Cheers.